Learning objectives. After studying this module, students will be able to understand limitation of averages, learn about need of dispersion measures, learn different ways of calculating dispersion, calculate dispersion using different methods, learn the difference between absolute and relative dispersion, know about Lorentz curve. Measures of dispersion. Introduction. What is dispersion? Dispersion tells us about the extent to which the values in a distribution is different from the average of distribution. There are many measures that help to find out the extent of variation, like range, quartile deviation, standard deviation, mean deviation. All these methods give a numerical value. But there is one graphical method also for measuring the dispersion. The difference between all these measures is that range and quartile deviation measure the dispersion by calculating the spread within which the value lie. Mean deviation and standard deviation find out the extent to which the values differs from the average. Measures based upon spread of values. Range. It is the difference between the largest and the smallest value in a distribution. R is equal to L minus S. The higher value of range signifies higher dispersion and lower value of range signifies lower dispersion. Range is a very simple method to understand and use. For example, pulse rate of one male residents of a certain village. Quartile deviation. If there is even one extremely high or low value range, then this range measurement is of no use. In such a situation, if the data is divided into 4 equal parts, each containing 25% of the values, we get the values of quartiles and median. The upper and lower quartiles are used to calculate interquartile range, which is Q3 minus Q1. Interquartile range is based upon middle 50% of the values in a distribution. Half of the interquartile range is called quartile deviation, QD. Thus, QD is also called as semi-interquartile range. Calculating quartile and range. Calculation of range and quartile deviation for ungrouped data. Let us understand this with one example. Calculate range and QD of the following observations: 20, 25, 29, 30, 35, 39, 41, 48, 51, 60 and 70. In this question, the range is clearly calculated as 70 minus 20 is equal to 50. To calculate quartile deviation, we need to calculate Q3 and Q1. Q1 is the size of n plus 1th upon 4 value. Here n is equal to 11. So, the Q1 would be the size of the third value. Then arrange the values in the ascending order and you will find that the third value is 29. In the same way, Q3 is equal to 3 n plus 1th upon 4 value. Ninth value would be 51. So, the Q3 is equal to 51. QD is equal to Q3 minus Q1 upon 2, which is equal to 51 minus 29 upon 2, which is equal to 11. Measures of dispersion from average. Range and quartile deviation are not helpful in measuring how far the values are from their average. two measures which can help us to find out deviation of the values from their average are mean deviation and standard deviation. As we know that the average is a central value, that is why some deviations are positive and some are negative. In case these are added the way they are, the sum will not reveal anything. In fact, the sum of deviations from arithmetic mean is always 0. Mean deviation. Mean deviation is the arithmetic mean of the differences of the values from their average. The average used is either the arithmetic mean or median. Calculating mean deviation. Methods to calculate mean deviation from arithmetic mean for ungrouped data. There are two methods to calculate mean deviation from arithmetic mean. Direct method. The average mean of the values is calculated. Then, difference between each value and arithmetic mean is calculated. The average mean of these differences is called as mean deviation. Mean deviation from median for ungrouped data. Calculate the median. Calculate the absolute deviations from median and denote them as mod D. Find the average of these absolute deviations, and that is mean deviation. Mean deviation from mean for continuous distribution. Calculate the mean of the distribution. Calculate absolute deviations. Multiply each absolute deviation with its related frequency to get F mod D values. Sum them up to get summation F mod D. Apply the given formula. Mean deviation x bar is equal to summation F mod D upon summation F. Standard deviation. Standard deviation is the positive square root of the mean of squared deviations from mean. So, if there are 5 values x1, x2, x3, x4 and x5, first we calculate their mean. Then deviations of the values from mean are calculated. These deviations are then squared. Positive square root of the variance is standard deviation. Calculation of standard deviation from ungrouped data. There are 4 methods to calculate standard deviation of individual values. All these methods gives the same standard deviations value. Calculating of standard deviation. Actual mean method. Suppose we have to calculate the standard deviation of the following values: 5, 10, 25, 30, 50. Assumed mean method. The assumed mean is a method for calculating the arithmetic mean and standard deviation of a data set. It simplifies calculating accurate values by hand. Direct method. We can also calculate standard deviation directly from the values without taking deviations. The formula is standard deviation is equal to under root summation x square upon n minus x bar square. Step deviation method. If the values are divisible by a common factor, then they can be so divided and standard deviation can be calculated from the values that come as result. The formula is standard deviation is equal to under root d dash square upon n into c. Standard deviation in continuous frequency distribution. Standard deviation can be calculated for grouped data by any of the following methods: actual mean method, assumed mean method, step deviation method. Actual mean method. The formula to calculate the standard deviation through actual mean method is standard deviation is equal to under root f d square upon n. Assumed mean method. The standard deviation can be calculated by taking deviations from an assumed mean. The formula is standard deviation is equal to under root summation fd square upon n minus summation fd upon n whole square. Step deviation method. In case the values of deviations are divisible by a common factor, the calculations can be simplified by the step deviation method. The formula is standard deviation is equal to under root summation fd dash square upon summation f minus summation fd dash upon summation f whole square into c. Absolute and relative measures of dispersion. The measures we discussed as of now are absolute measures of dispersion. They calculate a value which at times is difficult to interpret. Another drawback of absolute measures is that these measures give answer in the original values units. For example, if the values are expressed in kilometers, the dispersion will also be in kilometers. However, if the same values are expressed in meters, an absolute measure will give the answer in meters, and the value of dispersion will appear to be 1000 times. Relative dispersion. To control these problems, the relative measures of dispersion is introduced. Each absolute measure has a relative counterpart. Like, for range, the counterpart is coefficient of range. For mean, it is coefficient of mean. For standard deviation, the relative measure is called coefficient of variation, calculated as standard deviation upon arithmetic mean into 100. What is Lorenz curve? It is a graphical measure to estimate the inequalities in distribution. The Lorenz curve is a graphical representation of the distribution of income or of wealth. It was developed by Max O. Lorenz in 1905 for representing inequality of the wealth distribution. Lorenz curve uses the information expressed in a cumulative manner to indicate the degree of inequality. Summary. Let us summarize what we have learned in this module. Dispersion tells us about the extent to which the values in a distribution is different from the average of the distribution. Range is the difference between the largest and the smallest value in a distribution. In quartile deviation, if the data is divided into 4 equal parts, each containing 25% of the values, we get the values of quartiles and median. Two measures which can help us to find out deviation of the values from their average are mean deviation and standard deviation. Mean deviation is the arithmetic mean of the differences of the values from their average. The average used is either the arithmetic mean or median. There are two methods to calculate mean deviation from arithmetic mean. Standard deviation is the positive square root of the mean of squared deviations from mean. Lorenz curve is a graphical representation of the distribution of income or of wealth.